a lot of the feasibility study we did, which Nick, our analyst, did, was Denner and Heath looking at sites and trying to find this sort of thing. It needs the roof space, needs the connection, it needs the transformer there that we can connect to. Because the other alternative is Bradford can ask us to pay $100,000 or something like that to upgrade the transformer.
Having it here already is just a massive asset, and this is the sort of thing that we look for when we want to find sites for community batteries. The most appealing thing about this site was because of the current connection and infrastructure that was already here, that's been here for forever, we weren't required to make any alterations of any kind to the main switchboard in this facility, along with the sub-mains that then feed into the jail itself. So this board feeds the whole jail plus these 3 residential properties here as well.
Which has been good. So that means that during solar peak hours, there's local energy that's available for the battery to absorb and store.
It means the people that are on there now with their solar systems are able to export, but the new people coming on, typically a lot of them aren't able to export because there's too much.
I think in a town like Beechworth, you might have maybe 9, 10 sites that might have this capacity, but then with the ability to, fit rooftop solar and the battery, the load profile's got to suit as well. You probably narrowed that down to 3 or 4, and really we searched the whole of Beechworth, and this was definitely the best by a considerable margin. So each town's different, but a lot of your country towns, 3 or 4. Your bigger towns, like a Wodonga, I could probably find you 20.
The community itself, generally speaking, you can see it in there, it's pretty innocuous. It's using existing infrastructure, it's low key. We haven't ever had any pushback, and the Pixie guys in Denner can talk about, fire safety is often a big one, but they can talk about fire safety, so we've got good answers for that. So generally speaking, we haven't had any pushback.
These newer batteries, when you're talking fire safety and fire risk, they're nearly it's nearly an obsolete conversation now. They're that sophisticated, they're that smart, the technology in them and the way they're made is so much better that, for an example, there's now a standard that they have to follow, and they send their batteries off for testing, and basically what happens is they put them in a factory, they charge them up, they then actually try and set fire to the battery, and they simulate thermal runaway and document how the battery burns, how long it burns for, the heat, that sort of stuff. With Pixie in this factory, and it's a third party, so it's not Pixie trying to do it themselves and make their own documentation, it's an independent body. They couldn't get the Pixie battery to catch fire, even when they tried to set it on fire. So it's pretty impressive with...
Sort of information that would be really good to have more widely in the community.
It is, and it's pretty amazing with where they're getting to. Ours still has fire suppression, so if the battery did catch fire somehow, I'm not sure how it would, but it then has fire suppression. So basically, our conversation with CFA is to keep the doors closed and let the fire suppression do its thing, and it will suffocate the fire. It just releases a CO2 gas, a natural gas that suffocates the fire, and the fire can't continue. This is the main distribution board. So this board was incredibly old, actually older than the switchboard out there, just due to its age and the facility. It had completely rusted through, there was holes in it. All the old bus bar was cracking, which is an incredibly dangerous. Eventually that bus bar the insulation will flake off, and then it just takes one bug or something and it will just go, and it'd blow that whole door off, to be honest. So but it's a common thing. It's a common thing with old facilities. I've seen it plenty of times before, but probably the beauty of this project was we were able to replace it and give it a new lease on life. We had to design all the islanding functionality and grid protection relays and all that sort of stuff. This is one of the most sophisticated switchboards we've ever built, probably is the most. We were very restricted with space, which made it even more difficult. Like in a perfect world, I probably would have had the switchboard twice the size. In there, that's our brain. That controls the whole site, the operation, the off-grid functionality. Yeah, and then everything's done through these PLCs, but yeah.
Which are all remotely accessible.
Right. When you say batteries, where's your inverters?
Aha! Great question.
Keep going.
Wow. Oh, they just air hit me.
So they're all exactly the same. That's our inverters. They're that small.
Oh.
Yep. Each one of them's 3.3 kilowatt and can be changed hot. That's operating right now. Well, it's 230. Each one of those is 230, but when they combine, they do 415, which is three-phase voltage. So these are the battery stacks. These 7, we've got 112 kilowatt hours. We have 39 kilowatts of inverter. So these are 8. So these convert the battery to AC voltage that you use in your house. This system also is Pixie's first integrated DC coupled system. So we now have MPPTs up the top. So we have 30 kilowatts of solar over there that's about 8 years old. We have 35 kilowatts of solar over on the cafe. They are what we call AC coupled to the battery. So they use the existing network to charge the battery. But then what we have on that roof there, we have 35 kilowatts of solar connected directly via its DC current to the batteries. You know, when the grid goes down and it's isolated, the DC coupled solar can charge these batteries themselves without having to use the existing AC network in the jail.
With your batteries and your inverters, what's your cooling mechanism?
That's an air conditioner. It's a DC air conditioner that connects directly to the batteries. The inverters also have fans. So this is a controlled environment. It's about 21 degrees. If the grid goes down, that aircon still works because it's DC coupled directly to the batteries. And then, yeah, those cooling fans just pump air through the inverters and cycle it back through the bottom here.